Okay, if I were looking at this in competitive exam, certainly I'd be very nervous. Wouldn't know what question is easier, what question is difficult, but I'd make assumptions, and it looks like, I'm gonna say it looks like one might be easy for me to do. Looks like two relatively simple to do. It's a defined function that I could probably figure out what to do. Three looks tough to me. It's one of these sequences, and it's an implicit, so it looks like it might be a lot of work for me. But I'll go back to it later. Four complex numbers, I'll avoid that. And I say five looks reasonable. Now I'm going to just look at one at a time, and what I would say is two looks really reasonable for me. And what I mean by that, I can do this, and let me just do one at a time. Let me do this one here first. That looks relatively simple for me. Let's say it's going to be 1 over, let's see, b minus c would be 2 minus 3. And what do you get there? That would be 1 over minus 1, which is minus 1. So I'm going to say this number here is just minus 1. Let me go to the next one. I'll see what I can do over there. Let me cross this off. And let's see what I get there. A is 2. It looks like this is a confidence builder right now. And 3 minus 1. Well, 3 minus 1 is 2, so 2 over 2 is 1. So I'll write that down. Let me do this one over here. I'm going to cross this out. I'm done with that computation. And let's do this one. It's 3, and then I get, 1 minus, let's see, 1 minus 2, right? And that's going to be what? Let's see, 3 over minus 1, minus 3. Okay, so I'm going to cross that out. Now what I'm going to do, same thing I did before. All right, I'm going to use the function right over here. And what's that going to be? Let's see, the a is minus 1. And what's the b? The b is going to be what? 1. And then minus 1 minus 3 plus 3. What do you got over here? Minus 1 quarter. Now, I got to be honest with you. Mistakes happen. But I guess I'm not looking back now. But what I want to do is I want to point out we provide work for you. Let's take a look. Right over here. So this was an easy peasy lemon squeezy problem. All right. The next one I'd go to is probably number 5. So number 5, and I'm trying to get as many problems done as quickly as possible. I would say that this was a competitive exam at the high school level. And don't be discouraged, by the way. Not everyone is fast at this stuff over here. All right, but I think we did okay with this one over here. Let me just erase this business over here. We're done with this. We got minus 1 quarter. We got a correct answer. We were pretty quick at that one. All right, and again, I want to point out, I put work down here for you, and the work is on the very next page for you. And there's nothing wrong with looking at work if you need to. I look at work a lot sometimes. I say, how did someone do that problem? What I'm going to do is I'm going to do number 5 now. And I'm looking at it. It says, there's two triangles. Right, they're identical right triangles, by the way. All internal triangles are similar to the larger triangle. So what I'm going to do is I'm going to just label the sides over here. And I'll call this A. And I'll call this A. And I'll call this B. And I'll call this B. Let's see what their question is. It says, all internal triangles are similar to the large triangle. That's good to know. Which is larger, the pink area or the blue area? Well, I got to figure that out. So I'm going to just go through the first one, and I'm going to say there's, of the pink ones, there's 1, 2, 3, 4, 5, 6 of those triangles. Now, what's the area of one of those triangles? Well, looking at it, it would be 1/2 times the base. Well, the base is b over 3. And what's the height of those things? And again, I'm doing the pink guy over here. This is the pink guy. And what's the height of that? Well, it looks like a over 3. Let's see if I did that right. Count it right. 1, 2, 3, 4. Yeah, I did. And let's see what we get over there. 1/2 base times height. And what do you get there? I guess you get just BA, right? On top. And on bottom, what do you get? I got 2 and 3 gone. Over 3, right? Let me see if I did that right. Each triangle's base is b divided by 3, and the heights are a divided by 3. I did okay. Let me do this guy over here. How many triangles you got there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. What's the base going to be? It's 1/2 times the base. And the base looks like b over 4. And what's the height of this thing? It's a over 4. And what do you get there? Well, that's going to be a tough one, isn't it? So 2 goes into 2, 1 goes into 5 times. So what do you get? 5ba over 16. Well, now I'm comparing these guys, and I got to get a common denominator, because that's the way I like to compare things. And there's other ways to do it, of course, but I'm going to say, looking at that, 48, right? And what times 3 would be 48? 16. So this would be 16ba. And if I did this one over here, it's 15ba, because I'm multiplying top and bottom by 3, by the way, over 48. So which one's larger? Well, clearly the pink guy. This is larger. When I mean larger, the area of the pink triangles are larger than the area of the blue triangles. Let's take a look, see how we did. I'm scrolling around. And I see what they're saying over here. Yeah, pink is bigger than blue, as we expected. All right, I'm going to get my eraser out. My confidence is shooting up. And let me just... there's something scaring me, though, I'll be honest with you. We're finished with this one now. We're all done. All right, talk through it. We're good with that. All right, that wasn't so bad. All right, I'm going to go to another one. I'm going to do number 1. And I want to point out that if I were doing this, I'd say, oh my God, how many terms are there? There's going to be 12 terms. I'll write this down. x11 plus x10. And this might be killing time at this point. Now, if this was x to 1,000, I couldn't do this. But I want to write down, I want to talk about what I would do. I'm a little nervous right now, so I can just keep writing and maybe something will come to me. Wow, that's a lot of terms to write down, aren't there? I don't know if I can fit it in. So let's count her up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? Now, it's 11th degree polynomial. It's going to have 11 roots. I just don't know what the roots are, by the way. But I know the rational root theorem, and the rational root theorem, rational root theorem, I'm looking at potential roots, and they would be plus or minus 1. And that's nice, because I'm going to do that. I'm going to clearly say it would not be 1. So I'm going to say I think the rational root maybe is x equals minus 1. Well, I'm sorry, I said minus 1. Let me get my eraser out. Doesn't look right. So my confidence is starting to show up a little bit, but I could be very disappointed now. So what are we going to do? We're going to put this down now. We're going to check it out. And let me write it down for you, all right? So I would get minus 1, plus 1, 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 minus 1, plus 1 equals 0. 0, 0, 0, 0, 0, 0. I got success. So I know a root. Now, what were you told in your earlier pre-calculus classes? You were told to do a long division. And yeah, it might be tough, all right? But I know there's a root now. And if there's a root of x minus 1, what I'm going to be doing, let me get my eraser out. I'm going to erase this business over here. I don't really need it anymore. I know minus 1's a root. Let me erase this over here. And we're just talking through the problem, by the way. That's all we're doing. We're talking. So if minus 1's a root, I know there's a factor of this problem. And yeah, it's rather crude, by the way. So if you're quicker at it, that's great for you. But I'm going to do a long division now, because that's what you did in pre-calculus. And I'm going to divide through by x plus 1. Wow, that's going to be tough, isn't it? x10. And there's a nice pattern to it, though. And I could probably just get the pattern real quick, because I know the remainder is going to be 0. So that would be x11 plus x10. Well, wasn't that convenient? Then I get x9. You get the idea. I'll write this over here for you. Just go yada, yada, yada down to 1. And then when you get next plus x8, what would you get there? x9 plus x8. I think you're getting the idea that I'm going to get, the next thing would be I get the x7 now, right? So I'm starting to see x6 now. So I'm pretty comfortable now, all right? Let me just go towards the end, by the way. And what would I get towards the end? At some point, I'm going to be getting x squared, right? And what would x squared give you? It would give you x cubed. I know I'm going to get at some point plus x. And if I subtracted that, I'm sorry, x squared. Well, sorry about that. Then you're going to get x plus 1, right? And then would you, oh, plus 1. So what are you going to get if you do all that division? Let's take a look. All right, I'll write this down now. Get my little eraser out. Again, just thinking. It can't hurt to think, right? So I know what my division is going to produce. So I get, we already checked the root out. We know it's minus 1, so x plus 1 is a factor. And then what do you get? x10 plus x8 plus x6 plus x4 plus x squared plus 1 equals 0. And again, since I forget what the question is, and it's true, a lot of times when I'm doing something, I say, why did I do that? Well, I did that because they're asking me how many real roots there are. I know there's at least one. Right, I already found it, x equals minus 1. Then I'm looking at that second factor. I'm wondering, what would the roots of that look like? Well, I want to point out, if you look at this, every single term, regardless of numbers I choose in a real number system, would be positive. So this over here could have no real roots. It could have no real roots. So what am I going to say? There's only one real root. I'll say that, only one real root. So only one real root. One real root. And then it would have let's see, one real root. And then I said there would be, I'm starting to think about this now. I said one real root. Oh yeah, this makes sense. And why is that? There would be 10 imaginary. All right, and they occur in conjugate pair, by the way. So if you knew one, you know the other. Like, if one, again, I'm not going to go through that, but there's going to be 10 imaginary roots. Maybe I should say imaginary, I say complex. The a plus bi. All right, one real root. Let's see how we did. Number 1, right? And let's see what they did. Yeah, it looks like they did the same thing. And yeah, one real solution. All right, good news. Let me get my eraser out. We're done with that one. And let me go back up here. And now I'm on a run. So what do you mean you're on a run? I'm gonna tell you what we just completed. We got this one done. Feel good about that one. I got this one done. I got this one done. And I got 2 more to go, don't I? So now it's a coin flip. And certainly other people, they're looking at these things. They got their confidence built up. Maybe they attack the other ones, but I'm going to look at number 4. All right? Now, if 4 looks like it says a function f is defined where f of z is equal to I, and then it's that z with the bar on top. I want to tell you what the z with the bar on top is. A complex conjugate. All right? And then it goes on to say where I is the root of minus 1 and z is the complex conjugate of z. So z is equal to a plus bi. Z bar would equal what? It would equal a minus bi. That's a complex conjugate. Then they say it satisfies, how many solutions satisfy where both the absolute value of z, that's the modulus, is 5. Now what does that mean? It means a squared plus b squared is equal to 25. That's what that means over there. Now the other one says f of z would equal z. All right, let's see if we can figure that out. And let's see if we can do that. So what does f, well, let's write this down. So what's z? Well, I'm going to say z is a plus bi. Now, what does f do to z? It does this. So that would be I times the conjugate, right? What's the conjugate going to be? A minus bi. All right, maybe this is a dead end. Maybe you bark up the wrong tree and don't see what they got. What do you get over here? You get ai minus bi squared equals a plus bi. All right, what does this give you? This gives you b plus ai equals a plus bi. I'm looking at that now. What does that tell me? It tells me that a has to equal b. Well, maybe that's going to help me. So I'm going to say that a has to be identical to b. Well, let's put that in up here. So what we get. So you get a squared plus a squared is equal to 25. 2a squared is equal to 25. Again, you may forget the questions. That's fine. I'm just working on this. A squared equals 25 over 2, or a would equal plus or minus 5 over the root of 2. Now, if you're not comfortable with the way it's written, you can rewrite that differently. I don't think it's important to do that. But 5 root 2 over 2, and that's what a is. Now, what's our question? All right. Find a function f is defined this way. Z is a complex conjugate. How many values of z satisfy both this? Well, I found two. I want to tell you what they are. Z could be 5 over root 2 plus 5 over root 2 I, or z could be minus 5 over root 2 minus 5 over root 2 I. All right, so let's take a look at the key. It's a much more difficult question, by the way. I realize that. And let's take a look how we did. And let's take a look. Clearly you have two solutions, and they're written over here. All right. I want to point out that I'll expand that for you. It's going to be, plus or minus 5 root 2 over 2, plus or minus 5 root 2 over 2i. And if you wrote them down separately, it would be 5 root 2 over 2 plus 5 root 2 over 2i. And the other one would be minus 5 root 2 over 2 minus 5 root 2 over 2i. Yeah, two solutions. Clearly two solutions to that. These are tricky questions, by the way. I also want to point out, and I want to see if I did that for you. No, maybe not. Okay, so we've done quite a few problems already. I saved this guide, this one. It's really the toughest one there, and I'm just going to write down. T1 is 1, T2 is minus 1, and T3. Now here's how T3 is defined. Well, that looks like just 0 to me, and I'll tell you why. If I'm looking at that, if n is 3, this would be 0. All right, let me put T4 down for you. And what's T4 going to be? Well, 4 minus 3, which is 1. And then you would have 4 minus 1, which is 3. And then you would have times T. And then what are you going to get? Well, that would be 2, right? And then I'll put down T5. I'm doing okay, right? So it's 5 minus 3 is 2. And then what do you get? 5 minus 1, which is 4, times, well, now it's going to be 5 minus 2, and that would be T3, right? Well, that would be 0, all right? So this looks like, I'm going to say maybe that every odd one will be 0, and that seems to make sense now. But let's put down T6 now. What's that going to be? 3, and you get 5 times, I got to go back to, right, T4. And I'm starting to see that this really related to this one over here. Let's go to T7. And what's that going to be? Oh boy, I wouldn't want to have to go here. That's a lot of work to get there. I'm just seeing patterns, all I'm looking for. And what do you get over there? Well, let's see. What's it going to be? 1995, right? I'm taking 3 over 1990. What am I doing? I'm not going there. I'm sorry about that. That was wishful thinking. I can't go there. I'm going T7. We'll get there in a while. Don't worry about that. What's T7 going to be? 4. And then 7 minus 1 is 6 times, I go backwards 5. Well, you know what? I'm starting to see it again. This is going to give me 0. So I'm pretty comfortable now that, I'm looking at a pattern over here, and all the odd ones, T3, once I get past T1, by the way, all the odd ones are going to be 0. Why is that? They're going back to. So really what I'm concentrating on, these even ones over here. All right, I'm going to concentrate on the even ones. So I'm gonna write down T8 now. And what's T8 going to be? Well, let's take a look. That's going to be 8 minus 3, which is 5. I'm seeing something pretty nice now. And the bottom is going to be n minus 1. That's going to be 7. And then what do you get over there? That's going to be T6. I go back to, right? So again, I'm seeing it here. All right. So, I could write down T8 now. And what's that going to be? 5/7 times, well, T6. That's 3/5, right? 3/5 T4. Let me keep going. 5/7, 3/5. And what's T4? Oh, it's 1/3 times T2. Well, you know what? I'm starting to see a pattern. And I'll tell you what the pattern I'm seeing. I'm seeing that, this guy here is right over here, and this guy here is right over here. All right? Again, if you don't really see that, I guess you could go to the next thing, which would be T10. I wouldn't go to T9 because that's 0, but I'm going to go backwards now. And backwards to what? I really want to, dot, dot, dot. I want to get to T, let's make sure 1998, right? This is my wishful thinking. That's an even number. If it was odd, I'd just say 0. And what do you get over there? And again, you want to remind yourself, it's, 1995. I'm reducing it by 3. And what goes on bottom? Well, let's see, 1997. And then what goes there? Well, that would be T. I go backwards, 2. It would be 1996. And I could keep playing that game too. But I'm ready. I think I'm ready anyway. So let me write this down now. T 1998 is equal to 1995 over 1997 times. You know what? I don't think I need to write that down, but if you want to, you can. And what would you get? Well, you're just going backwards. You're going to get 1997, right? Now someone says, what are you doing over here? I want to point out what I'm doing. I definitely see a pattern. And the pattern is the tops are going down by 2. The bottoms are going down by 2 as well. All right? I'm sorry. I put, I said down by 2 and I went up by 2. So sorry. I got to erase that. Down by 2. Thank God I did say that. 3. And if I go down by 2 by 1997, you get 1995 times, I don't know if I want to keep going, but I guess I can. This would be 1991 over 1993. I'm just going to put dot, dot, dot. I know the pattern. What's this going to be? 5/7 times 3/5. You know what? I'm kind of jamming that in there, aren't I? I'll just erase it. I'll jam it in, but I'll make a better job of jamming it in. Dot, dot, dot. And you would get 5/7 times 3/5 times 1/3 times T2. All right. I'm going to start looking at it. And this is a 3 over here. It really does reduce quickly. And what I mean by that, 3, 3, 5, 5, 7, 7 would bear. And they keep going. Like there'd be a 1991 here. That would go, that would go, that would go. And what he left off with? Well, in the end, you left off with this. T 1998 equals 1 over 1997. And then what do you get? Times T2. Now, I can't remember what T2 is. So what I do, I go back and look, and it's -1. So what's my answer over here? -1 over 1997. Again, that's an even one. Let's take a look, see how we did. And if we did good, we did good. I'm seeing that over there. They did write some work down over here as well, and they say pattern inspection. Yeah, maybe they're more elaborate over there, but that's not bad. We're done, and we did pretty good, all right? Now, what I mean by that, certainly I have an advantage over you. I see the problem before you've seen them. But if you were a student doing this exam over here, again, my strategy, again, may not be the same strategy. It's not very good under pressure, I'll be honest with you. A lot of people aren't, by the way. I would not be discouraged by that. What I'd be encouraged by is that, that you're willing to work a problem. That's the most encouraging thing you got going, that you're willing to work one. So a lot of people look at these things and they're just totally discouraged. They don't try anything. They just say, oh, these are too tough for me. They're not. You can do these things, all right? So I'm going to claim over here, if I were doing it, I would hate to be under a time pressure, but I would try to do some problems that I could do initially. And remember what I said, I thought these were low-hanging fruit. I'll put the ones I thought were low. These two over here, in hindsight, are really low-hanging fruit. And then I'm going to say the higher-hanging fruit, maybe I would go to 1 next. That wasn't so bad. But, maybe I got confused on it. Maybe I got stuck on it, whatever. 4, if I gave it a little bit of thought, wasn't so bad. And 3, you know what, probably the toughest one in the set, but we got through that one as well. Again, thank you for paying attention.